Now let us discuss in detail the acidities of formic acid, acetic acid and chloroacetic acid. Now in formic acid there is a carboxylic acid group which can show resonance. The lone pair over oxygen atom shifts in this direction and simultaneously this pair of electrons shifts over oxygen atom. And we get O negative and O positive, positive charge being on the oxygen atom of the OH group and negative charge on the oxygen atom which was originally a C double bond O. Now this delta negative oxygen can induce a small inductive effect along the sigma bond here, so that this carbon acquires a delta negative charge and this oxygen attains a delta negative charge. Now delta positive oxygen can show a minus I effect. So here in the case of delta negative oxygen there is plus I, and here this oxygen shows minus I effect, and as a result the pair of electron will be slightly shifted towards this carbon, giving it a delta negative charge, and if this continues then oxygen should get a delta negative charge. And due to the minus I effect of this delta positive oxygen, this pair of electrons slightly shift towards the oxygen. So that should create a small delta negative at this oxygen, and that delta negative combined with this delta negative should possess a little more negative charge, but that is not sufficient enough to neutralize this delta positive charge much. Now again, due to the polarity of OH bonds, there will be slight shift of electron pair in between O and H towards oxygen atom. Now all these delta negative values will slightly decrease the delta positive value over this positive oxygen. So the acidity of carboxylic acid group will be decided by all these factors, but whatever be the plus I effect of delta negative oxygen, when it comes to the delta positive oxygen, its magnitude decreases. That is the net result. And so delta positive is not appreciably decreased, and so OH bond can ionize to give H positive and O negative. Now when we say formic acid is acidic, that means it is due to the resonance of the carboxylic acid group, which will give a delta positive charge over oxygen atom of the OH group, so that due to its delta positive charge, which is not decreased appreciably by the plus I effect of delta O negative oxygen or the electron shift of bonding pair between O and H towards oxygen, the oxygen atom is capable of taking up this pair of electron towards itself, removing H as H positive. But this carboxylic acid, that is formic acid, is not so appreciably acidic as any inorganic acid, and that is given by its pKa value of 3.751. pKa means negative log Ka, we have seen that, and as pKa increases, acidity decreases. So formic acid is acidic mainly due to resonance of the carboxylic acid group. When we come to acetic acid, the first thing to be mentioned is that the methyl group shows a plus I effect. So electron density or electron pair shifts towards this carbon from the methyl carbon. So methyl carbon will possess a delta negative charge due to the small polarity of 3 CH bonds. Now this carbon will possess delta negative charge. And we can say that this delta negative carbon can push this electron pair as well as this electron pair, that is the sigma bonded electron pair and the sigma bonded electron pair here. These two electron pairs can be shifted slightly, very slightly towards oxygen atoms. So very slight shift occurs here and very slight shift occurs here. So that electron density around this oxygen is increased. Now another factor which will decide the acidity of acetic acid is hyperconjugation of methyl group. Now hyperconjugation occurs by the shift of the CH bonds like this and simultaneous shift of the carbonyl group. Similarly, this CH bond can shift, this CH bond can shift, and when these shifts added together will give a partial negative charge over this oxygen atom, which is much more greater than the oxygen atom of the carbonyl group of formic acid. So both hyperconjugation and inductive effect pushes electron density towards carboxylic acid group. And then the delta negative oxygen by its plus I effect can push electrons pair towards this carbon, giving it a delta negative charge. And the inductive mechanism also provides delta negative charge. And again the delta positive oxygen atom pushes the electron density between electron pair between carbon and oxygen towards this oxygen. So you assume that a river is flowing in this direction, another river is flowing in this direction, and these rivers combine and flow in this direction. So there is combined electron density flow towards oxygen atom. So that the delta positive charge over oxygen atom in the OH group is much decreased than in the case of formic acid. So this oxygen atom will be showing a lesser tendency to absorb, take up the electron pair in the bond with the H. So that removal of H as H positive is not easy, made difficult, and so its acid strength will be lesser than that of formic acid. And the pK value is 4.756, which is higher than the pK value of formic acid, which is 3.751. So in the case of formic acid, there is no inductive effect, no hyperconjugation, only the resonance occurring in the carboxylic acid group and the combined inductive effect and minus I effect of oxygen atoms, combined plus I and minus I effect of oxygen atom is not sufficient enough to neutralize the delta positive charge over oxygen atom of the OH group in formic acid. And so it explains the acidity of formic acid. In a single sentence, the acidity of formic acid is due to resonance of the carboxylic acid group. In the case of acetic acid, there is inductive effect of methyl group flowing in the direction of the carboxylic acid group, and there is hyperconjugation of 3 methyl hydrogen atoms again flowing in the direction of the carboxylic acid group. So the combined electron flow will move towards the delta positive oxygen of the OH group, decreasing much the delta positive charge, so that the oxygen atom of the OH group with low positive charge, very low positive charge compared to oxygen atom of the OH group in formic acid will show a very low tendency to take up the electron pair in the OH group, so its acidity is lowered and hence pK value is increased. So that explains the acidity of acetic acid. So two things to remember: one, the plus I effect of methyl, and the other, the hyperconjugation of 3 methyl hydrogen atoms. Both increase the electron density in the carboxylic acid group, so that the oxygen atom of the OH group is electron dense, we say, and so it shows little tendency, very small tendency to take up the electron pair in the OH group. Now coming to chloroacetic acid. Chlorine is having an electronegativity equal to 3.2, which is comparable with the electronegativity of oxygen, which is 3.5. So we find that there is very small difference in electronegativity. Very small electronegativity difference between chlorine and oxygen. Chlorine exerts a minus I effect mainly, that is shown by these arrows, and the carbon of the carboxylic acid group attains a delta positive charge. Now carboxylate group or carboxylic acid group shows resonance, so that pi electron pairs are shared between oxygen through carbon to the other oxygen, so indicated by dot line here. Now hyperconjugation shows electron donating character. Here two hydrogen atoms, these two hydrogens can get involved in hyperconjugation. The bond will be shifting in this direction and a simultaneous shift over this oxygen atom. This bond will be shifting in this direction and again simultaneous shift over the oxygen atom, so that the delta negative charge can be of a little higher magnitude, so that it will induce a delta negative charge over the carbon atom of the carboxylic acid group. So the electron pair between this carbon and oxygen will be slightly pushed towards this carbon, and again due to delta positive charge over this oxygen atom, this electron pair may be slightly shifted towards this oxygen atom. But here the plus I effect of delta negative oxygen pushes the electron density between carbon and oxygen towards carbon, and then when we come to this carbon, the inductive effect operates in this direction and in this direction. So the inductive effect is divided between these two chains. A river flowing in this direction comes at a junction and flows into different directions, so that the electron density induced in the CO bond will be less, because part of the electron density moves over this chain towards chlorine. So the delta positive charge over oxygen atom is not much neutralized by the plus I effect of delta negative oxygen, and so the oxygen atom mostly carry the delta positive charge, which is less diminished by the plus I effect here, so that the main operating force is minus I effect of chlorine, And again, once again, the electron density shift in this direction, or electron pair shift in this direction, or electron density flow in this direction is divided between this chain and this chain. So the part of the electron density flow by inductive mechanism towards this chain is very less, so that around this oxygen atom the electron density will be less. So there is lesser decrease in delta positive than in the case of formic acid. So that chloroacetic acid is having a pKa value of 2.867, which is lesser than the pKa value of formic acid, which is 3.751. So pKa of formic acid is 3.751, and the pKa of chloroacetic acid is 2.867. Even though two hyperconjugations are operating, chlorine, due to its minus effect, partly withdraws the electron flow from electron density flow from the delta negative oxygen towards itself, preventing the flow towards the oxygen atom to some extent, so that the delta positive value here will be less decreased than in formic acid. So we can say chloroacetic acid is a stronger acid than formic acid and again acetic acid. So when we compare the acid strengths of formic acid, chloroacetic acid and acetic acid, formic acid with a pKa value of 3.751 and acetic acid with a pKa value of 4.756 and chloroacetic acid with a pKa value of 2.867, the acid strength of chloroacetic acid is the most, and the second comes formic acid, and the third comes acetic acid. So chloroacetic acid is stronger than formic acid, which is stronger than acetic acid. And in the case of chloroacetic acid, importance is given to mainly the minus effect of halogen, that is chlorine. But again, we should remember that there is resonance of the carboxylic acid group, there is hyperconjugation, and due to resonance, only the oxygen atom of the OH group can carry a delta positive charge, and hyperconjugation tends to donate electron density to the carboxylic acid group in order to decrease the extent of positive charge over the oxygen atom of the OH group, while minus I, strong minus I effect of chlorine withdraws electron density, and this withdrawal of electron density by chlorine is greater, and so the oxygen atom of the OH group still carry an appreciable amount of delta positive charge, which is more than in magnitude to that in formic acid, and hence chloroacetic acid is stronger than formic acid. And again, acetic acid, which is the least acidic among the three, provides electron density to the carboxylic acid group both by inductive mechanism and hyperconjugation. Now coming to another acid, that is benzoic acid. Now in benzoic acid, again there is resonance of the carboxylic acid group, creating a delta negative charge over oxygen atom of the C double bond O system, and a delta positive charge over the oxygen atom of the OH group. Now here the benzene ring, which is called the phenyl group, shows a plus mesomeric effect by shift of this pi electron pair in this direction and shift of this pi electron pair in this direction and this shift of pi electron pair in this direction and shift like this. So we get a delta negative charge for oxygen atom of the carbonyl group or C double bond O group and a delta positive charge over the oxygen atom of the OH group. Now during this shift the benzene ring carries a delta positive charge. So if mesomeric effect alone is considered, then we find that benzoic acid is a very weaker acid than acetic acid, because in acetic acid there is both inductive and hyperconjugation, and mesomeric effect is of greater strength than hyperconjugation or inductive. So there should be a greater pushing of electron density by the plus sum effect of phenyl group. This group is called the phenyl group. By the plus sum effect of phenyl group to the carboxylic acid group, thereby decreasing the positive charge, partial positive charge over the oxygen atom of the OH group to a greater extent. So benzoic acid should be a weaker acid than acetic acid, but it is found that benzoic acid is a stronger acid than acetic acid, but a weaker acid than formic acid. And this is because all the carbon atoms in the benzene ring are unsaturated. So there are 1, 2, 3, 4, 5 and 6 unsaturated carbons in benzene. 6 double bonded carbons in benzene. Now double bonded carbons are more electronegative than single bonded carbons. Again I said it is due to the less availability of the pi electrons which are overlapping in a region slightly away from the nuclei of the two atoms which form pi bonds. Hence they feel the deficiency or scarcity of electron. So they are more electron attracting, more electronegative. They show a tendency to attract electron pairs towards themselves. Hence we say the phenyl group exerts what is called a minus I effect. So the delta negative oxygen shows a plus I effect, and when this plus I effect comes to this carbon, it is divided towards the benzene ring as well as towards the positive oxygen. So part of the electron density passes to the benzene ring by inductive mechanism, and only a fraction is getting transferred to the oxygen atom of the OH group. So that there is not much decrease in delta positive as in the case of acetic acid. But since the mesomeric effect is a stronger effect, we can say the electron density present in the carboxylic acid group of formic acid and the electron density present in the carboxylic acid of benzoic acid when compared, since mesomeric effect is stronger, plus sum effect is stronger than any other effect, we can say there is a net increase in electron density in the carboxylic acid group of benzoic acid compared to formic acid, because in formic acid the carboxylic acid group is connected to hydrogen whose inductive effect is practically zero. There is a slight, very slight pushing of electron density towards carbon, and this is very slight because the electronegativity of carbon is 2.5 and that of hydrogen is 2.1, very small difference. There is only one hydrogen, so the pushing of electron density of hydrogen towards carbon may be practically neglected. So there is nearly zero I effect for hydrogen in formic acid, whereas there is a positive flow of electron density by plus mesomeric mechanism towards the carboxylic acid group in benzoic acid. And since the phenyl carbon atoms are unsaturated, there are 6 carbon atoms, so a strong minus I effect. So the plus I effect of delta negative oxygen atom is partially withdrawn by the phenyl group, and only a very small fraction is given to the delta positive oxygen, so that there is only a very small decrease in delta positive as compared to that in acetic acid. There is an appreciable decrease in the positive charge over oxygen atom in benzoic acid as compared to the positive oxygen atom in acetic acid. So in benzoic acid, we find there are 2 electronic effects operating in opposite direction, the plus M effect of phenyl group and the minus A effect of phenyl group. Both these effects are in the opposite direction, so that the electron density transferred to the positive oxygen by plus I effect of delta negative oxygen will be partially withdrawn by the phenyl group. So only part is given to the delta positive oxygen, so that the positive charge, magnitude of positive charge over the oxygen atom in benzoic acid will be higher than the partial positive charge over oxygen atom in the acetic acid molecule. So we say the OH bond in benzoic acid is more ionized than the OH bond in acetic acid, and benzoic acid possesses a pK value of 4.204, whereas in acetic acid the pK value is 4.756. Since benzoic acid possesses a lower pK value, you can say benzoic acid is more acidic than acetic acid, whereas formic acid there is no electron donation. In benzoic acid there is electron donation by a strong effect, that is plus some effect of phenyl group. When we compare formic acid and benzoic acid will be having a lower acid strength because there is an electron donation when compared to formic acid. So much about benzoic acid. Now, when we compare the minus I effects of halogen, we know that chlorine shows the most electronegative atom, being most electronegative atom, shows the most minus I effects, and chlorine comes second, bromine comes third, and iodine comes fourth. So when we compare the pK values of fluoroacetic acid, chloroacetic acid, bromoacetic acid, and iodoacetic acid, the pK values are 2.586, 2.867, 2.902, and 3.17. The pK values progressively increase, showing that acid strength progressively decreases, and the minus effect also progressively decreases. Now the position of halogen in a carboxylic acid can affect the acid strength. Now consider propionic acid. Propionic acid contains 1, 2, 3 carbon atoms, and here the functional group is the carboxylic acid group, and the carbon directly bonded to this functional group. This carbon is also called alpha carbon, and then the other carbon is called beta carbon. So we number the carbon 1 as the carbon of the carboxylic acid group, 2 and 3, or carbon 2 is called alpha carbon because it is directly bonded to the functional group. And this molecule containing a chlorine in the alpha position or 2 position can be called alpha chloropropionic acid or 2 chloropropionic acid. Similarly, There is another isomeric compound, beta chloropropionic acid. When the chlorine is in the alpha position, the second carbon, the alpha carbon, possesses a delta positive charge, and the carbon atom of the carboxylic acid group possesses a delta positive charge. When chlorine is connected to the third carbon or beta carbon, the alpha position possesses a delta positive charge, and the beta position possesses a delta positive charge, and the alpha position possesses delta positive charge. So that the carbon atom of the carboxylic acid possesses a delta positive charge. Here it possesses delta positive. Since delta positive is greater in magnitude than delta positive, we can say this positive carbon exerts a strong minus I effect than this delta positive carbon. So the magnitude of delta positive is less, so that the electron density in the carboxylic acid group will be higher than the electron density in the carboxylic acid group of alpha chloropropionic acid. In both cases, chlorine is the atom which shows, or group which shows, minus I effect. But when we come to the carboxylic acid group, due to the carbon atom possessing a higher extent of positive charge, we can say there is higher electron withdrawal from the carboxylic acid group in alpha chloro or 2-chloropropionic acid, whereas in 1-chloropropionic acid, since chlorine atom is far away compared to this isomer, and again the carboxylic acid carbon possesses a delta positive charge. There is very small withdrawal of electron density from the carboxylic acid group, so that the beta chloropropionic acid will be having a lower acid strength and a higher pK value compared to the isomeric alpha chloropropionic acid, which has a value of 2.84. So this is stronger than this is less stronger. So much about inductive effects examples. Thank you.